Hi, everyone. Thank you for joining our first ever online VMware Code meetup. For those of you who are new and this is your first time attending one of our meetups, VMware Code is VMware's developer community, and it's completely free to join. You just go to code.vmware.com/join, and you sign up with your email. Signing up gives you access to our code samples, many of which we update every single day, and our software development kits, our APIs, and our Slack channel, which has over 18,000 members, where you can find almost 75 active threads on specific topics like service mesh, Kubernetes, and as of today, even vSphere 7, which we just launched. We host monthly meetups on campus, but in light of recent events, we're choosing to keep them going, but online. So with that, I'll introduce our speakers today, Jim and Shooting. Thank you guys so much for coming today. Jim Bugwadia is the founder and CEO of Nirmata, the Kubernetes management plane for enterprises. Jim has been building large-scale distributed software for the last 2 decades. He started his career developing C++ software at Motorola for cellular network infrastructure, where his team launched the world's first CDMA network. Since then, Jim has held several developer, architect, and leadership roles at companies like Bell Labs, Cisco, Trapeze Networks, and Panalogic. Shooting Zhao is a software engineer at Nirmata working at Kyverno and several other cloud-native projects that help automate the deployment and operation of workloads in Kubernetes clusters. She started coding for a school project on software-defined networking and since has developed a keen interest in distributed systems. Shooting is a certified Kubernetes administrator since October 2018. If you guys have any questions, feel free to ask them in our YouTube chat as you think of them. Our speakers are dedicating the last couple minutes of their talk to answering them. And with that, I will hand it off to Shooting and Jim.
All right. Thanks, Kripa. Thanks for hosting this meetup. And hello, everyone. This is Shooting Zhao. And today, Jim and I are going to present Kyverno, which is a Kubernetes native policy management tool that can help you to manage your cluster configuration at scale. So before we start, I'm just going to give you a quick overview of what we're going to be covered today. So first, we'll talk about what is Kyverno and why people use Kyverno to manage your cluster configurations and how the Kyverno works. And then I'm going to give you some simple examples and to install Kyverno to a live cluster and also apply a few policies to your cluster and see what will happen. And then we'll come back to the more advanced features. And next, we'll talk about the roadmap and the contributing, how you can contribute to our open source project. And in the end, we'll have the Q&A session. We'll be ready to answer any of the questions if you have. All right. Again, since Kripa has already introduced herself, I'm just jump this and hand over to Jim, because he will be talking about what is Kyverno.
All right, thank you, Shooting. So first off, the main question we get when we introduce Kyverno is, what does the name mean, right? So let me start by talking about that. So Kyverno means govern in Greek, and we thought that's kind of fitting because one of the main use cases we're trying to address through Kyverno and through policy management is governance of Kubernetes clusters. So Kyverno is a policy engine which was designed specifically for Kubernetes. So what that means to users is it will use native patterns, native resources, as well as all the goodness that we love about Kubernetes, in terms of how resource controllers work, like pod controllers, deployments, etc. So all of these can, best practices can be leveraged by Kyverno to make policies just very familiar and intuitive to Kubernetes users. So first off, before we go further with Kyverno, let's talk about why you might want to consider policy management, right? So Kubernetes configurations are extremely powerful. They're declarative, which is great. They describe the intended state, and then Kubernetes controllers work hard on your behalf to make that state happen, right? So that's all good, but these same configurations can be very complex. And one of the challenges that we see with these configurations is there's a combination of roles involved in defining these configurations. For example, if you consider a deployment, about 20 to 30% of what's in a deployment may be what developers care about, but the remainder is what operations or cluster admins would care about. So how do you make sure that those configurations are properly coordinated? And how do you define a pipeline for those from dev test to staging to production? So there are several external configuration management tools, Helm and Customize being some popular options, which you can use. But where those tools, what they cannot do is enforce or make sure that provide some guarantees that the configurations that are applied to your cluster comply with your best practice policies, or even mutate configurations based on policies you might want to set. So policy management tools like Kyverno leverage a Kubernetes feature called admission controllers, where you can extend the logic that Kubernetes provides by plugging into the whole admission control chain, which means when the API server gets a request, a tool like Kyverno can then mutate, validate, and generate configurations and manage policies and rules. And the benefit here for end users is you don't have to write custom controllers. You're declaring rules in an easy to use language if you're using Kyverno, and those rules will translate into admission control for you. So why Kyverno, right? So there are other policy management tools for Kubernetes like K-Rails, OPA or OPA, which is Open Policy Agent. And those tools allow, K-Rails allows writing policies in Golang. With OPA, you can write policies in Rego, which is a language written specifically for policies. So the main reason why we created Kyverno is we wanted something very familiar to Kubernetes users. So make it easy for Kubernetes users, make it comply with best practices, patterns again in Kubernetes. And we wanted to make sure that not only can we validate and mutate configurations and handle any type in Kubernetes, right? Even custom resources, not just some predefined types, but then also make it very extensible and possible to generate new configurations, even new policies as needed based on your settings, based on your best practices. So let's take a look at how Kyverno works, right? So I mentioned that this feature of Kubernetes called an admission controller. So the way that works is if you write your own admission controller, which is Kyverno, it gets an admission review request every time there's a call to the API server. And that controller, based on whether it's a mutating or a validating controller, can either reject or review that request and even change some parameters or some data in that request. So what Kyverno does is you define your policies as Kubernetes resources. It builds up an in-memory cache of these for fast lookup and fast processing. And then as it gets an admission review request, it will either validate, mutate, or generate configurations based on your rules. And those will be passed back to the API server. So it's very fast, very efficient in how this gets reviewed as objects are being created or deleted or changed. And as an output from Kyverno, you get back validated resources. Kyverno can generate policy violations based on your settings. So if you don't want to block the request, but just report a violation, that's possible. And Kyverno will also add events to your pods, to your other workloads to make sure that any action taken by a policy is very easy to manage and view for the users. So let's take a look at what a Kyverno policy looks like, right? And we'll see many examples of this, but here's the high-level structure. So first off, a policy can contain multiple rules. Each rule has a match or exclude clause, and one of a mutate, validate, or generate clause. So the match and exclude use Kubernetes, again, features like resource kinds, resource and label selectors, right? And you can even put namespaces in either match or exclude, as well as you can use things from the admission request, like the user roles, user groups, and as you'll see in some of the more advanced features, even service account information can be used over here. So very powerful and easy in terms of matching, excluding exactly which resource you want to apply your rules to within a policy. And then once you select the object for processing, then you can apply a mutate, validate, or generate rule. And what this will do, obviously, as the names indicate, is either change the YAML or validate and if needed, block the application of that change to your cluster. So here's an example of a policy itself, right? So as you can see, it's very declarative, just like Kubernetes configurations. And just going through the structure here, you see like this policy matches one kind of resource, which is a pod, and then there's a message that you can customize, and you give a validation pattern, which you're using a feature of Kyverno called an any pattern. What that means is very simply that one of the patterns defined in the list has to match. So here, this policy is checking that either the pod has run as non-root set to true at the pod level, or that every container has that set to true. But as long as one of these conditions is met, the validation rule will pass. Right? So again, very simple and matches what the syntax that you would see in a pod or in a deployment in Kubernetes. Here's a couple of examples of mutate rules, right? So with Kyverno, you can either write a mutate rule as a JSON patch. So if you're familiar with that, that's an RFC for either adding, replacing, or changing things within JSON by indicating a path to that element. So here the operation is add, and based on this is showing how you can add an init container. So very simple, example which can inject an init container into your workload. The other examples here are using a different style. So Kyverno also support overlays. And if you're familiar with customize, overlays are a way of declaring a fragment of the YAML. So it doesn't have to be a complete YAML, but it's a fragment which will be overlaid on the target or on the source resource, right? So in this case, there's two overlays. One is doing, and we'll talk a little bit about these features later on, but it's doing a simple check to see if a port name is set to secure. Then it will set the port number to 6443. And the second one example is showing that if a port name is not specified, it will default it to 6443. Here's an example of a validate rule. So this rule is checking to see that the specific label is specified on your workload itself, right? So it's checking the metadata block and making sure that you have a label called app. So as you can see in the syntax, Kyverno supports wildcards for strings, and Kyverno also supports operators for numerical values. So you can do things like greater than, less than, which is extremely useful when managing things like resource quotas. Finally, an example of a generate rule, right? So generate is a very powerful feature in Kyverno, where based on a trigger, which could be the creation of any object in your Kubernetes cluster, you can generate additional configurations. Now, where this gets interesting, and one primary use case for this is with namespaces. So Kubernetes by default is not set up for multi-tenancy, but namespaces gives the beginnings of the building block for multi-tenancy. So using this feature of Kyverno, what you can do is set up the right resource quotas, the right role bindings, and the right network policies, things like that, all of which are required to secure your cluster, as well as you can enforce different pod security policies by generating configurations for a particular workload or a particular namespace. Another thing I mentioned is with Kyverno, you can choose to either block a request completely or you can report violations. So policy violations are first class, custom resources in Kubernetes. And the way Kyverno does it is basically it will create these violations in the namespace where the workload is running. So the namespace owners can see this too. And in the next slide, what we'll see is an example of a violation. So here it again looks like a Kubernetes resource, and it contains details about which workload, which resource is non-compliant, and also it contains details on which rule. So those are the two parts of a violation. along with the error message, which you can customize. In this example, it's giving you details about a pod, which is running as a root user, which is of course a security anti-pattern and not a best practice for production clusters. All right, so one other thing I want to address before I hand off to Shooting, and we'll see some Kyverno live in action, right? So one question we get often is, when should we use OPA? When should we use Kyverno? Or even other alternatives like K-Rails, right? So really it comes down to which language and what you're most comfortable with. So here we're seeing the same policy where this policy is requiring a read-only file system for your pod. We're seeing the same policy written in Rego, which is the language that OPA uses. And then on the right, we have that same policy written in Kyverno. So again, Rego it's very powerful, can do a lot of interesting things, but it has a learning curve. It requires learning that syntax, managing policies, much like you would manage other code or other programming languages. It's kind of something that needs to be learned and maintained. With Kyverno, our goal was to eliminate that learning curve for Kubernetes users, and again, make things simple. And as you can see, this policy, again, mirrors the structure of a Kubernetes pod and keeps things extremely easy there. So with that, let me hand off to Shooting, and we'll actually take a look at some of these features live with Kyverno.
All right, thanks, Jim. So as Jim has described, Kyverno supports a lot of policies like mutate, generate, and validate policies. And so for the first part of the demo, I'm going to show you 3 examples of those policies. And then I'm going to apply the policies to your incoming request, admission request, to see how that interact with the Kubernetes resource itself. So the first policy we have is a mutate policy, which will insert an annotation to your pods, which is using the local storage. Typically, Kubernetes autoscalers does not support to evict the pod, which is using the local storage. But if you want to make an exception for that, you can use the mutate policy to insert the annotations. And then for the validate policy, I'm going to show you that a policy to disallow pod is running at the root user. And with such policy, you can enforce your pod runtime security best practices. And then I'm going to show you a generate policy, which is triggered on the namespace creation, and it'll create the default resource quota to your namespace. Okay, let me switch to my cluster first. So today I'm going to use a Minikube cluster. It has a small compute resource, but I'm running a 115 Kubernetes cluster here. So before we start, I'm going to show you how to install Kyverno to your cluster. In our GitHub repo, we have this installation page to show you a few options that you can apply the Kyverno deployment to your cluster. But the simplest one is just pull the manifest from the repo and then apply it to your cluster. So I'm going to directly use kubectl create. And then you see a bunch of CRDs and RBAC resources has been deployed to your cluster. It will create the Kyverno namespace and it'll run as a deployment. Let's verify if it's running now. Cool. So now you have the Kyverno running in your cluster. It's pretty easy. And to jump to the first policy example, I have a mutate policy here, which is to insert this annotation to the pod, which is using the local storage type of mutate. And what I'm expecting is that if I deploy a pod with the mutate volume, I would see that I have this annotation added to my pod itself. So let's first apply the policy to the cluster. Just by kubectl create with the policy manifest. And then if you want to check what are the policies deployed to your cluster, you just do kubectl get cluster policy, and you will see the list. And we have the short name for that. It's called SAPO. You would also get the list of the policies. All right, that's the mutate policy I've already created. And then let's create the resource. So here is my resource. I have a single pod, which is using the volume untitled. And I would expect to see the annotation is added to the pod once it's deployed to the cluster. Okay, let's check. My pod is created. Let's get the manifest and see if the annotation is there. Awesome, I have the annotation inserted to my pod. So that's basically what the mutation policy looks like and how it works. Okay, let me clear my screen. And then we have a validate policy here. For a validate policy, we define a field called failure action. And now we set it to enforce, which means we will block your resource creation if one of your resources is violating the policy. So this is the policy Jim has mentioned before. It's validating your security context with this run as non-root field set to true. So this will prevent your pod from running as root user. And this is also the best practice when you want to run it in production. So let's first create the policy to the cluster. Again, to get the policy, you do kubectl get, and then we have this disallow root user. Let's look at the pod, the resource I have. So now you can see I comment out this security context, which means my pod is actually violating the previous validated policy. And since the validation failure action is set to enforce, I would expect Kyverno blocks my pod creation. Let's actually create the pod and see if it's gonna be blocked. Okay, cool. Now you can see we got some error here. It says admission webhook denying the request. And the resource is printed out here. It was blocked due to the following policies. And even you have the error message shown here. It's clearly tell you that which policy is blocking your resource. And if you do not block the resource creation, you can just change the failure action to audit. Let's go and modify the resource. If I do kubectl edit, cluster policy, here's the name. And then this time I want to change the failure action to audit and save it to the cluster. And then let's reapply the pod to the cluster and see if it's got created. Okay, cool. So now you can see you kind of set a soft standard to your policy, which actually allows the resource creation. But if you, like Jim has mentioned before, we create the policy violation for such scenario. And if you get class policy violation, you will see there is a violation created on this policy, and this is the resource information. And let's check what is inside this policy violation. You will have the resource information and the policy name, and also the message that why your resource is violating the policy. Okay, and then let's move to the generate policy. So here what I have defined is this generate policy will trigger on the namespace creation. And then whenever there's a new namespace created, I want to generate the default resource quota and also the limit range to this new namespace. And here I set the resource quota to a small range because I don't have that much resources. But it really depends on your cluster type and capability. You can customize this field. Okay, again, to apply the policy to your cluster, we do kubectl create. with the policy manifest. And then I want to create a new namespace. Let's do kubectl create namespace test. Okay. What I'm expect to see is that I have the default resource quota and limit range created inside this namespace. Let's do kubectl get resource quota. Cool. So you have a resource quota and also the limit range. This is what we defined in the policy itself. All right. Since I've shown you some basic policies, we have these best practice policies. I added a link here. You can also check it on our GitHub repo. We have these sample policies, which are defines the best practices for your production-ready cluster. Feel free to check it out. All right, let me hand over to Jim. He will be talking about more advanced features.
Thank you, Shooting. So excellent demo. And as you saw, very easy to validate configurations, mutate configurations, and even generate defaults for namespaces or any other objects, right? But what else? Like, so that's great. We can do all of those basics. Also, like Shooting said, like, things like you can cover in your pod security policies. We've also defined the best practices. So that's something you should check out. But let's talk about more features, right? More advanced features. So first off, Kyverno is using YAML. So how do you add conditional logic to YAML? And that was one problem we had to solve. So we designed a feature called anchors. And as we'll see, both for mutate and validate, with some lightweight syntax, it's very straightforward to add some conditional checks to your YAMLs. Secondly, the other challenge we ran into is how do you do things like variable substitutions, right? So sometimes in your policies, you're not going to be able to statically define all the information you require. And the policy data has to change based on the context itself. Then we'll look at another feature called preconditions, which lets you selectively apply or not apply a policy based on variable data. And we'll look at two other features, which is the auto generation of pod controller policies, extremely powerful again in Kubernetes, leveraging the owner resource patterns. And then we'll talk about the Kubernetes CLI or Kyverno CLI and how it can plug into kubectl. So let's start with anchors, right? So we already looked at some examples of this, if you recall, in one of the earlier slides. But when I showed that mutate policy, what we were able to do is if the port name was set to secure, we wanted to set a particular value, and that was done by this first anchor type. The other example I'd shown is if a port name or if a port number was not present, so if that tag itself was left out, then Kyverno would inject that tag. But if the user had specified a value, we would leave it alone. So that would be done by the second, the add if not present type of anchor. For validation, there's more conditionals, right? And there's more fine-grained checks that you can do. So the first is a very simple conditional, which also does an if. And you're in the example, what we're showing is if your image tag is latest, then you want to enforce that the image pull policy cannot be if not present, just for best practices and to make sure, again, in a multi-tenant production best scenario, you are always pulling or getting the right image there. The second anchor type is an equality anchor. So it's saying if host path is specified, then it cannot be set to varlib, which means that because you don't want to allow certain secure directories on your system to be exposed to workloads, to be exposed to user pods, so you can easily now check for that, and only if it's specified, then you cannot set that path to varlib, right? The third anchor for validation is an existence anchor. And this is useful for when you have a list resource, like a list of containers. And here, we have a somewhat contrived example, but what it's showing is that if you have a list of containers, you want to make sure that Nginx latest is inserted as one of the containers in the list. But this could apply to other things like a list of ports or any other list type that you have in your YAML. And finally, the negation anchor, that what that's useful for is making sure that a certain tag cannot be specified. So if you want to completely block host path from being used, all you need to do is use this X and the parentheses, and that tag cannot be specified in the incoming YAML then. So pretty easy to add some conditional logic into your YAMLs. The other feature I want to talk about is variable substitution, right? So like we said, sometimes you want to vary the policy data, the output, based on what the context of the policy is. And in this case, the context is actually the resource object being processed in the API request, as well as some of the resource metadata, like who's invoking that request itself. So both of these, Kyverno builds a context for every rule that's being processed, and that data is now available for while you're processing that request to be used within your policies itself. The syntax that we've chosen in Kyverno is very familiar. It's JMES path. So kubectl uses this, and other tools like even AWS's CLI uses this. So pretty straightforward to use, a well-defined syntax, not some language we invented, but very familiar to users. And here, for example, if you want to refer to the reference the object, the resource data, so you would just say request that object. But the user data, like let's say you want to use the username, it would be request.userinfo.username. There's also some built-in variables which we found through real-world examples around multi-tenancy use cases, service account names, service account namespaces. So Kyverno automatically computes these variables and puts them in the context in case you want to reference them in your policies. So while variable substitution allows you to change the policy data, preconditions allows you to change whether a rule is applied or not, again, based on context information. So here what we're showing is based on a variable, which is service account name. So if that service account name is, here in this case, is specified, then we don't want to apply a particular rule, for example, or perhaps we want to enforce that that rule is applied. So preconditions can choose to do that. And the way you would do it, again, it's very straightforward syntax, but what they're controlling is whether the rule itself is applied or not. All right, so another feature of Kyverno, and this is a good example of how Kyverno leverages best practices and patterns existing in Kubernetes. So ideally, you want to apply policies to all pods, regardless of how the pod was created, whether it's a deployment, a stateful set, a job, cron job, shouldn't really matter, right? Um, but you don't want to have to write policies on each one of these controllers. And also, you don't want, when somebody is applying the deployment YAML, you want to give the policy feedback at that point and not later when the pod is run by the controller itself, right? So how do you solve all these problems? So the solution that we came up with is with Kyverno, you can write policies at the pod level. And then Kyverno will, because it's familiar with Kubernetes workload APIs and the object model, it can automatically generate policies for different controllers based on an annotation. So by default, the value is all, and it automatically generates, if you write a policy for a pod, it will automatically apply to deployment, stateful sets, jobs, cron jobs, etc. But you can control this, you can change this in your policy if you wish. All right, so finally, and the fifth feature I want to highlight is a CLI. So Kyverno also, one thing we've thought about quite a bit is how do you test policies before you apply them to your cluster? So two things you can do. With the CLI, you can validate policy syntax offline without even requiring a cluster. Most of the validation, unless you're using policies for CRs, all of that validation can be done statically through the CLI. And you can also apply policies to a cluster without putting that policy inside of the cluster. So even before you actually deploy that policy, you can test the results and see what it would do. And then you can, if it's safe, if everything works as expected, then you can put that policy in your cluster and have it apply. So lots of features, but let's take a look at this in action. So again, I'm going to hand off to Shooting, and she's going to show us some of these features live.
All right. Okay. Then, yeah, since Jim has already described those more advanced features, I can't wait to show it in our demo. So for the first one, Jim has described that we support the variable substitutions and also the preconditions in the Kyverno policy. And with this variable substitution, we have some built-in variables, and also you can fetch data from the admission request. For example, I have this mutate policy, which is, again, insert the annotation. But in this case, I have this, I want to add the value as the service account name. And even if you want to get the username of your admission request, you will be able to define a field called request.username, userinfo.username, or you just want to fetch the metadata, you can customize this field accordingly. And let's take a look at this policy, what it does. So here I have a policy name defined add namespace access control, which will basically generate some default RBAC rules for your new namespace. Again, first is the mutate policy, and the next I'm going to generate the cluster role whenever there's a new namespace created. And this cluster role is basically to delete the namespace with this incoming namespace name itself. And also, if I have a cluster role, I may want to create another cluster role binding to bind to the previous cluster role to let your service account have that permissions. Okay, then let me go to my cluster. Just a little background about the setup I have. I'm running Minikube, and now by default, I'm using the cluster context Minikube. But I have also created another tenant or another cluster user, which is for today's demo. Let me get the context. I have this demo Kyverno service account created, and I'm the owner of the demo namespace. Okay, so now I have two users in this cluster. And with this generate policy I have shown you, whenever I create a new namespace, I would also expect the Kyverno will create these RBAC objects into the new namespace itself. So let's first, again, create the policy. Remember me the name. It's always hard to remember the name. Okay, it's called NS access. As access control. Then again, to verify the policy, there we have. So you can see the cluster policy is there. And then I will use this kubeconfig to create the new namespace, and there I have the service account defined. So I'm gonna pass in the kubeconfig, and also I'm going to create the namespace called test2. Okay. So before that, I think I have I found myself the kubectl auth command, which is really helpful to list all the permissions you can have. Before I have the permission to create the namespace, but with the new that test2 namespace being created, I can see I have another permission added to this service account, which is to delete the namespace itself, right? Okay, then for another feature, which is the auto-generate policies for pod controller, what it means is that whenever you have a policy defined on your pod level, Kyverno will automatically generate another additional rule for your pod controllers. Again, this is a policy we have used before, which is to disallow your pod to run as a root user. But the difference here is with the previous policy, I think I have set this annotation to null, which means I want to disable this feature. But then with the new policy, I set the value to deployment, which means I want the Kyverno to generate an additional rule, which is applied to deployment itself. All right, then let's create this policy to the cluster. Then create controllers, verify it. So we have this auto-gen policy created. And then let's look at the manifest of this policy. What I'm expecting to see is that I have the deployment. I have the rule applied to the deployment. Okay, so now you can see we have two rules. The first one is what I defined in my manifest, which is applied to the pod itself. But in additional, we have another rule applied to the deployment, and the name is prefixed with the autogen. So this rule is automatically generated by Kyverno, and the spec itself is converted to the pod controller's template. All right, since I have the failure action here set to enforce, which means when I create the deployment, I would expect to see it will be blocked by the Kyverno itself. Again, this is the same pod, but I wrap it in the deployment. And here I don't have the security context set as well. So let's create the deployment to the cluster. Okay, again, you see this? Kyverno automatically block the resource creation. This is really helpful if you wanna define the policy on the low level, which is the pod level, but Kyverno will automatically convert it to the pod controllers, and it'll apply to your pod controllers results. All right, and you may want to say, what if you don't have a cluster running, or you don't want to actually create the policy to your cluster? Even Kyverno won't impact any of the existing workload. The CLI here can help on that. Again, go back to our GitHub repo. We have this Kyverno CLI page, which will show you how to build the CLI and how you can use the CLI. Basically, to build the CLI binary, you just need to clone our repo, and we have a makefile for you. After the binary is built, you may want to put it to your directory, and you will be able to run it anywhere. So now, let me open up another terminal. Now I'm inside the Kyverno repo itself. You can either use the make CLI command to build the binary, or if you want to install to your Go path, I can do Go install with the path to Kyverno CLI itself. What it does is to install the Kyverno as a kubectl plugin, and also add it to your Go path. And then if you do kubectl Kyverno --help, you can see all the available commands for you. Right? Then let's go back to my demo folder. Again, go back to the first policy I have, which is the mutation policy. I want to insert the annotation to my pod itself. You can use it, you can test it with the CLI. What I want to do is I want to do Kyverno apply with the policy manifest. And then you can specify a resource, and the CLI will apply the policy to this resource. Okay, so here's the output. It says applying policy to your resource, and here is the resource, is the result. You can see the annotation is successfully added to the pod manifest. So in this way, you can test the CLI locally, even without the cluster. And also we have the Kyverno validate command, which will be helpful to validate the policy schema and to check if you have any syntax error when you define the policy. All right, let me go back to our slides and talk about our roadmap. And if you're interested in contributing, we'll show you how to do that. Okay, so what some of the features we're currently working on is that, for example, with the generate policy, we're not only allowed to generate the resources, but also we're allowed to clone from the existing resources. And you may wondering that if your if your if your original resource has changed, you may want to sync the changes to your generated resource. And again, for the variable substitutions, we now can fetch data from the admission request. But what if you want to fetch the data from the external resources, like if you have a config map deployed to your cluster? And we would also want to support to query the data from those type of resources. And that's one of the use cases of these variable substitutions. And you may also want to do some more fine-grained access control, like what I have demoed. You want to generate some RBAC objects to your new namespace to build your multi-tenancy environment. Or if you want to allow or deny some certain type of operations based on the request details, we would be able to do that. All right, coming to the contributing part, it's not necessary that you submit a PR and write some code, but also we would like your use cases or the feature requests. If you have any of the policy you want us to support, feel free to join our Slack channel. We can chat there offline. And if you're playing with around this Kyverno and saw some bugs, we are also welcome you to log any bug issues on our repo. Okay, to jump to the summary and some takeaways, we have introduced what is Kyverno and how policies are useful in managing Kubernetes configurations at scale. And also, since Kyverno is built for Kubernetes, it can validate, mutate, generate configurations. Kyverno also supports those best practices, and it's available on our GitHub page. It is helpful for your pod security and isolation. And what I have shown you, it's really easy to install to your cluster and get started with it. And feel free to import it to your cluster and try the best practice policies. And any of the feedback, we would love to hear back from you. All right, thanks. That's pretty much we have today. And if you have some questions, we are ready for those.
Hi, guys. I'm going to hop back on video. Thank you so much. First of all, awesome talk. I'd just like to remind everyone that's watching, if you have any questions, please feel free to send them in the YouTube chat. We do have a question. Somebody was asking, how do you compare Kyverno with Gatekeeper?
Right. So I can give a quick context, and then Shooting, if you want to add more details, please jump in. So Gatekeeper writes some constraints, but underneath it's also using OPA and Rego, right? So it does make OPA a little bit easier to use with Kubernetes. So of course that's one alternative, but again, the challenge we see with that, and what some of our users and what we heard from the community, is the fact that you have to still manage policies with Rego, and have to kind of either use pre-built libraries or learn that programming language became the biggest sort of challenge to deploying and using that. Shooting, anything more you want to
I think I totally agree. And since Kyverno is native to Kubernetes, it's really similar to the built-in Kubernetes objects. You can easily get started with and write your own policies.
So we have one more question that's not related to Kyverno, but what is the auto-completion feature, Shooting, that you're using in your environment?
Right. So I think for most of our best practice policies we define is at pod level. And typically you won't deploy a single standalone pod in your cluster or any of the workload. you would always want to run as a deployment or some other pod controllers objects. So we found it really helpful to start with this feature. So we built that.
So Shooting, I think the question was actually on your command line, on your shell, right? You're using a, yes, so like the auto completion you use on your shell?
Oh, that one.
With Z
Actually,
shell, maybe?
I'm using Zash with
Okay.
an auto completion plugin
Right.
to run them online, but yeah, I'm using Zash.
It's impressive how quickly you go through those commands. So
Yeah, I think it's really helpful.
And I think that's our last question. There's only two. So thank you guys so much for being our first speakers at our virtual code meetup. I could not have asked for better speakers. You guys are so great to work with and awesome talk. Hopefully we have another meetup sometime soon. So
yep. Thank you, Kripa, and the entire VMware code team, and thanks to all the audience. Take care.
bye.
Thank you.
Bye-bye.